Hello everyone and welcome back to your second section in chapter 2, which a reminder is all about logarithms and exponential functions. Specifically today we are going to focus on both of those, but we won't be graphing today, we will be evaluating, which is where our learning target is going to come from. I can evaluate logarithmic expressions. Technically that should say I can evaluate logarithmic and exponential expressions. But you'll see in the very near future, in the next few minutes, that those are almost interchangeable. A reminder of our last class, we looked at graphing exponential functions and graphing logarithmic functions. And the way that we were able to do all of that content in one class period is with the understanding that exponentials and logarithmic functions are inverses of each other. Meaning, if we swap an exponential function's x values and y values, then we will have its inverse, which is a logarithmic function. You're going to see today, when we start evaluating these expressions, that it's going to be very similar. Now, we won't be swapping x and y values because, in fact, we won't actually see variables today for the most part. We won't see x values and y values. That is because we're going to be dealing with expressions. Expressions do not have an equal sign. Think about it. An equation has the root word equal in it. That is why an equation has an equal sign. An expression does not. So we won't have any x and y values or variables to swap, but instead we're going to have multiple properties that help us evaluate these expressions, and in a way it's the process of swapping around some items. I will tell you that there is a lot of content, a lot of rules and formulas that you are going to have to learn and commit to memory to be successful for this chapter. If you are in my Math 111 class, then on Wolfden you can actually find a PDF form with all of these rules and formulas on it. I think it's called 5.2 through 5.3 property sheet, and it is under your resources tab in your handouts. So I would encourage you to pull that out or pull that up on a device, maybe print that out or something, maybe print it out or copy it down after this. It is built into this video as well, but I wanted to put it all into one document for you to make it easier for you to study. We'll be using that for today's class. So, without further ado, here we go. So, here's the thing about today's class. Because it is full of so many properties and so many rules, there's not going to be a lot of teaching going on, because it's all I can really do is give you the rules and talk through those rules, and then from there you have to practice applying them. So there's not really a process that I can really explain or teach to you other than here's a list of these properties, now let's practice trying to apply some of those. So keep that in mind. If you get to the end of today's lesson and you go, I'm confused and I don't know what she was saying, that's because you've got to learn those properties. And a lot of you are just going to have to memorize these, because there's not a way that I can teach you this. This is just, here are the rules. This is how it is. I will do the best of my abilities to show you some ways that I've remembered some things. And that typically, as usual, involves some kind of like color coding or color pencil, color pen type thing, and I'll show you that. But here's our first set of rules or properties. Remember, a logarithm is just the inverse of an exponential function. And so this first property kind of walks you through that. I've got y equals log base b of x. Remember, we learned how to say that and read that last class. Y equals log base b of x if and only if its exponential inverse is also true. X equals b to the y power, base b to the y power. Now, here's that first major shortcut that I want to that I want to show you, and I'm going to use this over and over and over again in today's class. How do I rewrite this logarithm into an exponential form? Because that's ultimately what this property is telling you, is that because they're inverses, I can rewrite a log as an exponential function, or I can rewrite an exponential as a log. And so that's our first big step today. If you don't get anything else today, that is the one big takeaway that I want you to have, is how do I rewrite logarithms as exponentials and vice versa. Here is how I would show you how to do this. So over here on this side, okay, I've got y equals log base b of x. Now if I want to rewrite that as an exponential, I always want to start with my base. So my base is b, and I'm going to draw an arrow over to this number, okay? And then from there, I'm going to come back over to what I'm taking the log of. This is something you'll hear me refer to as go around the world, because you're just drawing arrows in a big hoop there. I want you to pay attention to that process again though. Base b to the y and then back over to the x. Now compare that to the exponential over here. Okay? B to the y, x. Okay? If I rewrite that, that would be b to the y equals x. Compare that to the exponential functions writing. It's the exact same thing. Now they're written on two different sides, but remember that is we can swap those sides. Just like we can say x equals 2 or 2 equals x, we can change those up. But that's kind of the big thing that I want you to take away from this property, and I really want you to hang on to for today's class. I'll show you that one more time. B to the y power equals x. Okay? B to the y power equals x, and I'm getting that from just going around the world. Now, the next thing, what if I gave you an exponential and I said rewrite this exponential function as a logarithm? Well, we're going to do the same thing. We're going to start with the base. So over here on this side, what is the base of this exponential? The base is b. Okay? So I'm going to start here, and I'm going to go around the world. So I'm going to go b over to the x and then back to the y. Start with the base, which is b, over to the x and then back to the y. Now I want to rewrite this as a logarithm, so it will be log base b, and the next thing that I would write would be log base b of x, and then the last thing is equals y. Log base b of x equals y. And so that is why I like to use the around the world method, and that is just something that I came up with, that name. It helps me remember I need to be drawing arrows to rewrite these things, and that will help me evaluate my logarithms. Alright, so there's your first and most important property of the day. That doesn't mean that's the only one you learn, but that means it's the first one because it's so important. Okay? Now, what if we're dealing with a natural logarithm? Remember, a natural logarithm is written as ln, and it always has a base of e. Remember, e is that irrational number that we're rounding to the nearest tenth, which is about 2.7. Okay, so same concept here. If I want to rewrite this logarithm as an exponential, the base, even though it's not written, we should know by now from last class, the base is e. So e to the y power equals x. Now if I wanted to rewrite this side, this exponential, as a logarithm, I would start with the base e, go over to the x, back to the y. So if it's given to me as an exponential, a good rule of thumb is my first step in evaluating something could be, if it's given to me as an exponential, let me rewrite it as the logarithm. So log base e of x equals y. Log base e of x equals y. Okay. Now, one of the properties that we're going to see in the next couple slides is that when you have a log base e of something, that's the same thing as the natural log of that something. So you could have just as easily written the natural log of x equals y for this problem. In fact, you could do that for almost all of these. Up here up top, we could have written, if the base was e, we could have rewritten it using the natural log as well. Okay. This third property is very similar. It's again relying on you to be able to rewrite a logarithm as an exponential. But this third property is also just letting you know something that we talked about last class. If you see a log and there is no base written, okay, again, if you see a log and there is no base written, then you automatically assume that your base is 10. You automatically assume that your base is 10. If you have a logarithm, okay, that has a base that is not written, then we understand it to be a base 10. Okay? And so then, again, go around the world. 10 to the y power equals x. 10 to the y power equals x. And that is exactly what we have written over here on this side. 10 to the y power equals x. If I want to rewrite this exponential as a logarithm, start with the base of 10, go to the x to the y. Log base 10 of x equals y. So those are your first three properties, and they all are literally revolve around the world. How do you rewrite a logarithm into an exponential? How do you rewrite an exponential into a logarithm? And then other things like the natural log always has a base of e, and then something called a common log. That's just if a logarithm doesn't have a base written, then it's base 10. Okay? Now the reason why we need these is in the next slide or so I'm going to say evaluate this expression or evaluate this log. And you may not know what log base 5 of 70 is, but you can rewrite that as an exponential and then figure it out. And so that's kind of where we're heading. For right now, we're just going to practice rewriting some of these. Okay, so here's your chance. On the left-hand column, you are going to rewrite these logarithms. You're not evaluating it. You are just rewriting the left column, rewrite those logs in exponential form. And then on the right column, you're going to rewrite those exponentials into logarithmic form. So pause this video, jot down these 7 examples. It shouldn't take you very long. And all you're going to do is do around the world and rewrite these into their inverse form. Okay, so here are all 7 rewritten in the proper format based on the directions. If you need to pause the video to jot down some answers or to correct yours, do that now. And then there are a couple of things that I just want to address with you. Okay, so look up here at the top left-hand corner with the red handwriting. Log base 6 of 36 equals 2. Okay, I've been looking at logarithms for a while, and still my brain doesn't process what log base 6 of 36 is immediately. But if I rewrite that as an exponential, 6 squared equals 36, my brain processes that immediately as, yeah, that's correct. Same thing with the one in blue. My brain doesn't process immediately log base 3 of 81, what that equals. But my brain can very quickly say 3 to the 4th power is 81. Sure, check. Okay. The second and third thing that I want to draw your attention to is this green option. There are some fractions hanging out here. We have got to make sure that we remember, and I'm not teaching this is something that you should already know, and if not, you're going to have to take some time on your own to study this. Okay? But we have got to remember and recall that numbers raised to a fraction power do something. Okay? We have to know that, especially since we're not supposed to be using our calculators right now. Okay? So a reminder, because you're going to see it again in this lesson, you're going to see it next lesson, you're going to see it on your test, a reminder that when something is raised to a fraction, it's going to change the format of how that number is written, or specifically when a base is raised to a fractional power, it's going to change how that number looks and how you treat it. When something is raised to a fractional power, remember that fractional powers are the same thing as some type of radical or root. So for this example, 289 to the 1/2 power, that's the same thing as the square root of 289. So if something was raised to the third power, to the 1/3 power, let's say 27 was raised to the 1/3 power, that's the same thing as taking the cubic root of 27. And those are things that you should know already. If you don't, then you need to get on Khan Academy or YouTube, find some additional resources or some additional practice with exponents that are fractions. Okay? Because those are definitely going to come into play in this chapter, and you should already know it. You're going to have to know it. Same thing with this, the bottom left-hand corner that's in like this golden orange color. Okay. What does it mean when something is raised to a negative power or a negative number power? 14 to the negative 2. Okay. That's the same thing as saying 1 over 14 squared. Okay. Anytime you are taking a base and raising it to a negative power, you are in essence taking its reciprocal and then doing something with it. So 14 to the negative 2 power is 1 over 14 squared. If it was 6 to the negative 5th power, that would be 1 over 6 to the 5th power. Okay. And again, those are some rules that you should know. Those are things that you learned in middle school and early high school. So you definitely have got to know them and use them. If you don't, then make a note in your notes to Google, YouTube, find them on Khan Academy, power rules or exponent rules, fraction exponent rules, negative exponent rules, and dig up some practice on that because we're definitely going to be using it. Okay. So here are a couple more examples. I'm not going to talk through these, but I will work through them silently, so I'll let the video play, but I would encourage you to pause the video and see if you can do these on your own as well. check your answers and make sure that you were able to rewrite these equations. Notice that these are equations because they have an equal sign, but not all of these will be equations. Some of these will be open-ended, or they will be an expression, which is what we are working towards. This is what we will end class with. If you do have any that you have questions about, make a note of them in your notes and include that specific example in your check-in email with me later today. Okay. So here is a set of what it looks to be a seemingly very long list of properties. I'm going to try and help you eliminate some of these in just a second. But the first one that I want to address, it's actually reviewing what I said on an earlier slide. If you have a logarithm that has a base of e, that is the same thing as the natural log base e of x. So that just allows you to rewrite it in a different format. Okay. Now jumping back up to this list of dual fours here, I have these properties written this way because they match up exactly with the logarithm and the natural logarithm. So in all reality, if you learn one set, then you know the other set. Okay? So if you want to just learn these four over here and then just remember all of those properties work for natural logs as well, then you don't have 8 properties to memorize all of a sudden. You're down to 4. Okay? Some of you may need to learn all 8. If that's you, go for it. But I don't think that you need to do that. If you are genuinely studying, you really only need to learn these 4 and then remember that a natural log has the same exact properties. Its base is just 3. Okay? So I'm going to talk through one side of these. I'm going to talk through the actual logarithms over here on the left-hand side, and then the natural logarithms are going to be the same exact thing. You just need to decide if you're going to learn 8, if you're going to learn 4, what you're going to do there. Okay? This first property says log base a of 1 equals 0. That's your property. Okay? Now here's the reason why. If I rewrite that as an exponential function, that would be base a to the 0 power equals 1. Anything to the 0 power is 1. So that is what this property says. For me, I don't memorize this property. I don't fill my brain up with extra stuff. If I know the around the world method of base to here equals this, then I don't have to remember log base a of 1 equals 0, because I will figure it out by knowing the around the world method. If you would prefer to learn the property, that's fine. Learn it. Here it is. It's here for you to study. Log of whatever base of 1 equals 0. So log base 10 of 1 is equal to 0. Log base 500 of 1 equals 0. Whatever your base is, if it's log base whatever of 1, that's going to always equal 0. In a similar fashion, this second property on the left-hand side is going to function the same way. This is the property. Log base a of a will always equal 1. So log base 2 of 2 is always going to be 1. Log base 30 of 30 is always 1. Why is that? Well, around the world method again, a to the 1 power is always going to be a. A number raised to the first power will always be that number. That's why it works over here in the natural logs. My understood base e to the 1 power will always be e. This third property is going to, again, explain itself using that around the world method. This is one that I would potentially study and learn just because it looks very funny. Okay? Log base a of a to the x equals x. So log base 2 of 2 to the x equals x. Why does that work? Well, base raised to the x power equals base to the x power. Okay? A to the x power equals a to the x power. That's why this property works. So you may want to take some time to learn or memorize that property. Okay? It works the same way in the exponential form as well, but the exponential form is a little weird. You've got a raised to that power. So a raised to the log base a of x power. That's very weird to look at, but that's what you've got written down here. A raised to the log base a of x power equals x. Okay? That might be one that you want to memorize and study. Okay? How do I know that it's true? Around the world, start with the base. The exponential base is a to the x and back. So if that's written, this is an exponential form. If I rewrite that as a logarithm, it would be log base a of x equals this, equals log base a of x, which is a true statement. Okay. Another way that a lot of people think of it, and it is not mathematically correct, so hear me when I say that this is not a formula, this is not a rule, it's really just kind of a shortcut. When your exponential base is the same thing as your log's base in the exponent, then a lot of people think about it as canceling those out and these equal each other. If you want to think of it this way, please hear me again when I say that it is not mathematically correct or sound to just say you're going to cancel that out. You are not canceling anything out. That is just kind of a visual way of seeing if the base of the exponential function is the same as its logarithmic base in the exponent, then I can ignore what's happening here and say this is my answer. Whatever x is my answer. Okay? Now this last one is one that you absolutely have to memorize. It's the only one that can't really be explained nicely using the around the world method. Okay? But this one is still a very simple property. You still have to learn it, but it's still a very simple property. Here's what this property says. If the log base a of x equals the log base a of y, then x equals y. I just want you to take a second, read that again if you need to, and see if you can figure out how that makes sense. If log base a of x equals log base a of y. So it's kind of the same concept as the shortcut that I just showed you. It's not mathematically sound, but it is very easy to remember in this way. If you got two logarithms that equal each other and they have the same base, these two both have base a, then I can drop the log base part and just take the x and the y and set them equal to each other. Okay? So if I had, let's say I had log base 7 of 2x equals log base 7 of 22. Based on this property, I would be able to say both of these pieces have log base 7. I can drop the log base 7 and then set what's left equal to each other and get my answer. Okay. Now it works the same way with the natural log, and since these are so different, this property is just a little different than everything else. I want to walk through this one with you. Okay. The natural log, remember, if over here at this one, if the natural log base e of x equals the natural log base e of y, okay, these are both the natural logs of e. I can drop the natural log of e, and what's left is equal to each other. So there are your properties. Let's see if we can actually apply them and work through some evaluating of some logarithms and exponentials. Okay? So these are our 8 that we'll take a look at. These are the last ones that we'll take a look at, and then the last sheet is your practice. I'm going to ask you to include your answers to a couple of these in your check-in email. So make sure that you do the practice at the very end of this slide. And I will make sure to include the work and the answers there. But I want to make sure that you paid attention and that you actually work through them yourself as well. But we will do these 8 together before I turn you loose and let you do some practice on your own. So here we go. We're going to evaluate or use our properties of logs and natural logs. And so here are our 8 we want to evaluate. Okay, so let's just start with number 1. Number one, I want to evaluate log base pi of pi squared. I want to know what that equals. Okay, that would be the same thing as what's 2 plus 3 equal. That's an expression. And you would tell me what that is. You would tell me it's 5. So I want to know what log base pi of pi squared is. Okay? Well, if you remember the property, you can go straight to an answer. Or if you're like me, I don't necessarily remember all of those individual properties. I remember the around the world method. Okay, so I'm wanting to know what is log base pi of pi squared equal. So I'm going to do my around the world method. Well, Miss Windsor, where am I going with that? Well, here's how you would do it. Start with your base like you would any other time. Pi, draw to the other side. Well, nothing is there. Fine, that's fine. Put something there. You can put a variable there if you want. I usually just put a question mark. Pi, question mark, back to pi squared. So I'm rewriting a logarithm, okay, because nobody, unless you know the property, nobody can say log base pi squared equals blah, blah, blah. But we can rewrite this as an exponential, as its inverse, and see what our answer is very quickly. So that's what I'm going to do for almost all of these. I'm going to rewrite this logarithm as an exponential. Pi to what power equals pi squared? Pi to what power equals pi squared? Answer is 2. Okay. This question mark has to be 2 in order for it to equal pi to the 2 power. Okay. And that's it. Some of these are that simple. Okay. Let's move on to the second one. We've got log base 2 of 1 over 32. I want to know what that equals. Okay, so I want to know what does this equal. Again, if you don't want to use a question mark there, you can use a variable. If you want to say log base 2 of 1 over 32 equals x, that's fine with me. Either way, most of us don't know what log base 2 of 1 over 32 equals. But I can rewrite this logarithm as an exponential or as an exponent and get an answer a lot faster than just staring at this log. And so again, that's what I'm going to do. 2 to what power equals this? 2 to what power equals 1 over 32? Now this looks fairly complicated, and the reason why is because we're looking at 2 to a power equal to a fraction. But what I want you to remember is if we back up, everybody remember right here. Everybody remember in the orange, the bottom left-hand corner, how we can rewrite numbers raised to a power. We can rewrite them as fractions. Okay, we're going to have to do that in some situations, and this is a prime example of that. For us to be able to say 2 to what power equals blank, we're going to want to rewrite 1 over 32 out of being a fraction. We don't want it to be a fraction. We might want to rewrite that as 32 to some power, or 32 to the negative 1 power. Those are the same thing. Okay? If that was a struggle for you, if that blew your mind, then that is a giveaway and a obvious indicator that you need to go practice those fractional powers and those negative powers before you get in over your head with all this content and don't know what to do. Okay? But I can rewrite 1 over 32 as 32 to the negative 1 power. Okay? So now we're getting somewhere. Okay? 2 to what power equals 32 to the negative 1 power. I want to pause right here for a second and just say that you have done the new material in this step. This is the new material. Rewriting that logarithm as an exponential. This step is not new. Now it looks new, but it's not new. This step is just number sense. It's just, how can I rewrite 32 to help me understand 2? Or better yet, think of it this way. I'm trying to figure out 2 to what power equals 32. Okay? Specifically equals 32 to the negative 1 power. Okay? So think about it. Okay? If we can rewrite these two things with the same base, then we will have our answer. Just like we did in the first problem up here, we had pi to what power equals pi squared. Because the bases were the same, we knew the powers equaled each other. So we need to do that same process in this problem. I need to rewrite 32 with a base of 2. So here's what I need you to think through. How can I rewrite 32 with a base of 2? Okay. Is 2 a factor of 32? Walk through that with me. 2 to the 1 power is 2. 2 to the second power is 4. 2 cubed is 8. 2 to the fourth power is 16. 2 to the fifth power is 32. So I can rewrite 32 with a base of 2 raised to the fifth power. Don't forget that negative sign. Bring it down. And then the left side of my problem. Okay. 2 to what power equals 32 to the negative 1 power? That's not going to work for us. We have to rewrite 32 having the same base as 2. But if I know my numbers, if I know my factors like I'm supposed to, I know that I can rewrite 32 using 2. And it's 2 to the fifth power. Keep your negative sign. Now, if the bases are the same, what do you know about the powers? They are the same. Okay. So my answer is negative 5. I know that that is confusing. Okay. It's not supposed to be easy. This is the last thing that we're doing in this class, so it's going to be challenging. It's going to be one of the hardest things that we've done potentially all year long. You're going to have to study. You're going to have to brush up on your factors. All these things that you've learned in the past are coming to fruition. You're going to have to use them. Okay? And if you're struggling with that, let me know, and I'll pull some examples for you, and I can send them out so that you've got plenty of good practice. Or I'll try to find some practice problems with some answers included for you to walk through. But this is definitely one of the hardest ones on this page. Okay. Number 3 looks just like one of those properties that we wrote down a few minutes ago. 5 to the log base 5 of 3 power. I want to know what that equals. Okay? And we have a property that states this exactly. So if you know the property, you can go straight to your answer of it's 3. Okay? But if you don't know that property, which right now I'm thinking that a lot of you maybe don't, maybe you're looking at that property sheet that's on Wolf Den, maybe you're looking at your notes, that's what you should be doing. Okay? But maybe you're not quite sure about it yet. Remember that this is a situation, again, where you can rewrite it using the around the world method. Okay? So I want to know what 5 to the log base 5 of 3 power equals. This is an exponential function. I can figure out what it equals by rewriting it as a logarithm. Okay, so around the world, here we go. Log base 5 of something. You can use a question mark, you can use a variable x, whatever. Equals log base 5 of 3. And so when I rewrite this as a logarithm, I think that you can probably see what your answer is very quickly. Okay? When I rewrite it, I've got log base 5 of something equals log base 5 of 3. Remember, if logs have the same base, I can drop it, and what's left is my answer, which is 3. Okay? Remember, another kind of shortcut way is if you have an exponential expression that is raised to a log, if the bases are the same, so if the exponential base is the same as the log's base, you can cancel those out. Cancel loosely. You're not actually canceling anything. You can drop them, and your answer is what's left, which is, again, 3. So for that problem, you can either just know the property immediately and get an answer, or you can kind of reason through it. Either way, you should be able to get to your answer fairly quickly. Number 4, we've got log to the 1/7 base, or log base 1/7 of 49. I want to know what that equals. Okay. Again, it's written as a logarithm. I don't know what that equals off the top of my head, but I do know, instead of wasting time, my first step can always be rewrite it into its inverse. This is a log. Maybe I can try rewriting it as an exponential. So start with the base, around the world, and back. 1/7 to some power equals 49. Okay. And now here we are again. We're dealing with a fraction raised to a power, or a fraction and some power somewhere within the problem. You can do this a couple different ways. You can either rewrite 49 as a fraction, or my suggestion would be rewrite 1/7 using a negative exponent. Okay. I will take you back to the beginning again, right here. Okay, down there in the orange. Remember, I can rewrite a fraction as a number, as a whole number with a negative exponent. So I can rewrite 1 over 14 squared as 14 to the negative 2 power. Okay. So if I bounce back to this problem, I can rewrite 1/7 to some power. I can rewrite that as 7 to a negative something. Okay, and if you want to use x here, you can. You can rewrite it as 7 to the negative x power. However you want to flow through that. Okay. We're still sitting at a place where, if I'm thinking through all those properties, the bases had to be the same on all those properties for this to work. And so I've got a base of 7, and then on the right hand side I got a base of 49. Can I rewrite one of those bases to be like the other? Okay. Can I rewrite one of those bases to be like the other? And this is where that number sense of those factors and those multiplication tables from elementary school are so important. Okay? Because when I look at this, I immediately start thinking, well, 49 can be rewritten as 7 squared. It's a perfect square. 7 is a factor of 49. I can rewrite 49 as base 7 raised to the second power. Okay. And so now this is what I'm looking at. Okay. 7 to the negative something power equals 7 squared. When your bases are the same, I can drop the bases and whatever's left is my answer. So negative question mark or negative x equals 2. What does my answer have to be for this to be true? Negative 1 times something equals a positive 2. My answer is negative 2. Okay? Think about it. Negative times negative 2 would be positive 2. Okay? And so my answer is negative 2. Okay? At any point in time, if you need to pause the video, rewind it, and watch it again, or if you need to pause it and jot down a question that you have, do that. I'm going to stop prompting you and telling you to do that. You just do it when you need to. Okay? For number 5 looks very different from all the others. Number 5 is an actual equation. Okay, and I know that because an equal sign is written in the problem and given to me. Okay. And so I have log base 4 of x plus 7 equals log base 4 of 14. Okay. Now, if you get in a hurry and you're like me, you get into the pattern of, okay, around the world, here we go. Base 4 to this equals that. Okay, and so I'd have 4 to the log base 4 of 14 equals x plus 7. Okay. And now, to me, I know that I can solve that, but to a lot of you, that may just look really messy. It may look just as messy as number 5, or the original problem of number 5. But you can still solve it. Here's what I want you to see. 4 to the log base 4 of 14. When your exponent's base and then the log's base are the same, I can drop it, leaving me with this. So 14 equals x plus 7, and my answer is 7. So that's one way that you could solve this, again, by going around the world and getting your answer. The other thing that you could do is just know the property from the earlier slide. Let me take you back to that earlier property. Okay, here it is sitting on this page. Okay. When you have two logarithms that are equal to each other, if they have the same base, I can drop the log base and what's left is equal. So look at number 5. Log base 4 of x plus 7 equals log base 4 of 14. The log bases are equal. They're the same. So based on that property, I can drop the log base 4s and what's left is equal. X plus 7 equals 14. Subtract 7 on both sides, and there's my answer again. Hopefully you're starting to see that there's a couple different ways that you can do each of these problems. There is usually a shorter and easier way, but that doesn't mean that you can't get there in a variety of ways. Number 6. To me, number 6, aside from number 2, number 6 is probably the most difficult problem on this paper. And the only reason why I say that is because it requires the most number sense. It's not that the logarithmic part or the exponential part is very difficult. It's the number sense part that's difficult. Let's get into it, and we'll see why here in a second. Okay. Number 6, log base 9 of 27. I want to know what that equals. Okay. And so I'm thinking through my properties. The one that always helps me the most, again, is around the world. So I've got a logarithm. I'm going to rewrite it as its inverse, as an exponent, or as an exponential expression. 9 to what power equals 27? 9 to what power equals 27? Okay. Do you know 9 to what power equals 27? Okay. Start walking through that. 9 to the 1 power is 9. 9 squared is 81. So immediately we've already busted. Right now this isn't going to work. Okay. There's nothing that we know of that's a whole number that can help us say 9 to something equals 27. This is why I think that this is one of the most difficult problems. When we run into a situation like this where 9 to some power equals 27 is just not possible to our brains, then we have to rewrite both sides into a new base. Okay? And that is very advanced critical thinking math for a lot of us. Okay? But I just want you to think through it. Think about 9. Think about 27. What is a common factor that they have? What is a common factor that they have? Hopefully you are saying 3. Okay? So hang with me for a sec. Definitely put a star by this one because it's a very difficult problem, I think at least. Maybe it's not for you. If it's not, great. But I think it's very difficult. Okay? How would I rewrite 9 to some power as a base of 3? Okay? So how would I rewrite that as 3 with a base? Okay? So first, 3 to what power is 9? 3 squared. Okay? But don't forget, you got to keep our question mark or our variable up here. Okay? I can rewrite 9 to some power as 3 to the 2 times something power. Okay? On the right hand side, how could I rewrite 27 with a base of 3? So start going through your exponents there. 3 to the 1 power is 3. 3 squared is 9. 3 cubed is 27. Okay? So I can rewrite 27 as 3 cubed. Okay? And again, I haven't done it yet. I'll go ahead. I'll do it for us here. If you don't like using the question mark, you can use the variable x. It'll work the same way. Okay. Now we're seeing how this might start to work. We've got 3 to the 2 times x power equals 3 to the 3rd power. Here is a property that we have learned, or a common sense thing that a lot of us can spot. When the bases are the same, you can drop the base and what's left is equal. So 2 times something equals 3. Well, how do I find the something, or how do I find the variable x? Divided by 2 on both sides. And our answer is 3 halves. Our answer is 3 halves. Now, nobody that I know of, at least in this class, could say 9 to the 3 halves power equals 27. Right? None of us have those math skills that I know of. If you are, you're good. You're really good. Okay? But most of us, how about that? I'll say most of us. Most of us are not very good at looking at something like that and thinking about fractional exponents. Okay? That's why we needed to rewrite both sides with the same or the common base. Okay? I would strongly advise you put a star by that one. If you need some more practice, that would be something that you could include in your email to me, and I can dig up some more practice problems like that. Number 7, I've got log base 8 of 3x minus 10 equals log base 8 of 5. Remember, you could do the around the world process and you could say 8 to the log base 8 of 5 power equals 3x minus 10, and you could solve it that way. Or you can recall the property that says if your log's bases are the same and they are equal to each other, I can drop the log base and what's left is equal. So 3x minus 10 equals 5. Add 10 to both sides. 3x equals 15 and x equals 5. Last example problem for the day, and then I'll turn you loose for you to have some practice, and then maybe you can work on some homework practice, and then you can email me with any of your questions. But our last one that we will do together is number 8. We've got log base square root of 11 equals 121. Okay. Now, same thing. I don't know what log base root 11 of 121 equals, but I can rewrite that as an exponent or as an exponential expression by doing the around the world method. So square root of 11 to the x power equals 121. Let me take you back to an earlier slide. In the green, remember that numbers raised to a fractional power can be rewritten as a radical or as a root. Okay? So if they're raised to the 1/2 power, that's a square root. But that works the other way around. Say you are given a square root number. I can rewrite that number with a 1/2 power. Okay? So go back to our last problem. I've got the square root of 11 to the x power equals 121. I don't know how to work with that because I've got a square root on one side raised to a power and then a whole number on the other side. I really need to rewrite the square root of 11 as a number raised to a power. And the only way that I can do that is by saying 11, the square root of 11 is the same thing as 11 raised to the 1/2 power. But don't forget, you still have an x up there. That is the whole purpose of this problem. I'm looking for that missing piece. I can rewrite the square root of 11 to the x power as 11 to the 1/2 power times x in that power equals 121. Now these bases are not the same, but you should, and if not, you got to develop that number sense. How can I rewrite 121 with a base? Okay, can I rewrite it with a base of 11 is the first question. Okay, can I rewrite 121 as an exponent term with a base of 11? Okay, so start going through your powers of 11 and see if you get to 121. What is 11 to the 1 power? 11. What is 11 squared? 121. So yes, absolutely. I can rewrite 121 as 11 squared. The bases are now the same. When the bases are the same and equal to each other, I can drop the bases, and what's left is equal. I've got 1/2 x equals 2. I need to know what x equals. Solve for that missing piece. Multiply by the reciprocal on both sides. All right, that should be 2 over 1. 2 over 1 And my answer is 4. So the square root of 11 to the 4th power equals 121. Or log base square root of 11 of 121 equals 4. Now I know that that was a lot. That was probably one of the most complicated lessons that we've had all semester, and for good reason. We're building up to more and more difficult content. Okay? So I expect a lot of emails with questions. I expect requests for extra practice. Let me know today so that I can get them to you. Okay? I'm not going to be handing those out a week from now, right before your test. I need to know in your email today, and I will get those sent out to you. Okay? On your next slide, you've got 12 practice problems, and I do want you to do them all. Okay? We haven't used the full length of our normal class period, so that means you've still got some time that you should be dedicating to this class to do some practice. Okay? So I want you to pause this video, and I want you to start working through these 12. I am only going to post the answers in this video to each of these. I'm not going to show you how I got them. I'm just going to give you the answers because I want to know if you actually know what the heck you're doing. Okay? Because if you don't, we need to find out and clean that up now rather than it's the day of the test and you're emailing me saying, I don't know what I'm doing. Okay? You need to know today, or at best tomorrow, I really don't get this. I need some extra help. Okay? So pause this video, work through these 12. Whichever ones you're having issues with, email those to me, and we can talk through them. Or depending on responses from people, we may schedule a Zoom session to work through these and talk through them and answer some questions. Okay? Other than that, that is all I have for you. Do these 12 practice. If you're still confused but you just need a little extra, go to your homework for this section and try some more practice from your homework, and then send me an email saying, I don't get this, this, ... Okay, be specific in what you say you don't get. I don't want to hear, I don't get logs. I'm going to say, I'm sorry, rewatch the video. Okay. Be specific in which questions you don't understand, and then we can work from there. Okay. I will catch up with you all soon. Let me know what questions you have, and make sure to send me your check-in email before midnight tonight.